Okay, it says recording. All right, so what I'd like to do is I'd like to share my screen. For those of you who are watching at home, I forgot to start the recording a little bit sooner, so you missed a little bit of the lecture. But we're talking about chapter 15, okay? So this is a fun little demonstration. Let's say that the Stanford Binet IQ test is normally distributed with a mean of 100 and a standard deviation of 10. We're going to simulate 900 with a uniform distribution. Okay? Now, have we talked a little bit about the uniform distribution before? That's right. It's going to be a rectangle, right? Okay? So here's what we're going to do. When we do this simulation, what we're going to do is we're going to pick a bunch of random numbers. So I'm going to pick random numbers. I want them to be between 75 and 125. Okay? So here's what we're going to do. We're going to go over 9 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And then we're going to go down 100 rows. I should have done this. No, that's right. Well, let's go back up 1 row. I went down 1 too many rows. Perfect. Okay, so I've got a count of 900 students. I'm going to copy this and I'm going to paste special so that the values don't change. Okay, so these are random numbers, right?
How'd you do that? So they don't change? Because that's so like.
Oh, how do you do that? That's a good question. So I went rand between 75 and 125. Okay, and you notice, so this number, it keeps changing and the other numbers don't. So when you're doing your projects, which we're giving you the green light to do, okay, here's what you do. So you can pick a bunch of random numbers. You can pick between 1 and 100 or whatever you want to do. And so what you do is you highlight all of your numbers like this, and then you right click and you say copy, okay? And then you right click again, and then you click on the 1, 2, 3 paste special values. And what it does is it changes that value from a random number. Now when I type, that number doesn't change.
You just select it, right click, paste special values.
Yeah, copy and then paste special values, right? Okay? All right, so now I'm going to use the cheater method. Except for, well, I don't know if I like this cheater method. We're going to see if it's good, but hopefully 900 is big enough. We're going to make a histogram. And what do you expect the histogram to look like? A uniform distribution, which is a straight line, a rectangle. Okay. So we're going to go to recommended charts. We're going to go to histogram. Well, it's kind of a rectangle. Part of this is because they use goofy, stupid. This is why I don't like the histogram maker, but that should look more like a rectangle than it does.
Now,
okay?
When we make our histograms, I see that numbers are overlapping, and that should not be happening.
Well, so here's what they do, okay? You remember what the parentheses and the square brackets mean? This is 75 to 86 included. This is 86 is not included, which is dumb. Another reason why I don't like the histogram maker. Okay? I'll bet you, maybe, well, I don't want to waste time. I bet you if we made our histogram in groups of, say, 10, it would look like a rectangle. Okay? So, but we're going to, I don't want to waste time on that. Okay? All right. So at any rate, does it look like a bell? No, and in fact, even though it doesn't look like a rectangle, how would you describe this graph? Right skewed, right? It would be, well, we're not expecting linear You're thinking of correlation. We're not talking about correlation. We're talking about the distribution, okay? So this is clearly a right-skewed distribution, correct? Okay? All right, so now, here's what I want to do. So let's pretend these 900 numbers represent 900 students in a school, okay? So now, let's say that I wanted to find the mean of each row. Let's pretend, since there are a bunch of random numbers, that these are random students, and each row represents a random sample of 9. Okay? So the question I have is, how would I find the mean for this row? Equals average. Okay? So I'm going to find the mean of this row. Now it says that the mean should be 100 and the standard deviation should be 15. Okay? On this first row, I got a mean of 97.8, which is pretty close to 100, right? Okay? I'm going to copy this down to the bottom. Okay? So you can see there's some variation. We go from 98 to 105 to 99 to 98, 102. Okay? So there's going to be some variation going on, right? Okay? Now, when you're thinking about your projects, you should think about them because what we are utilizing is the central limit theorem. This will especially be true when you're doing the mean. So this is not a proportion, right? This is continuous data. These are we're finding a sample mean. So think of your potatoes or your speed limit test. This is going to apply to them. Okay. One group, let's say Ashley's group, let's pretend that the speed limit was 100 miles an hour, which it won't be, but let's pretend, and she got a speed limit of 97.8, and let's pretend that Lindsay's group. Okay, I got it. It just took me a second. Lindsay's group did it, and they got 105 miles an hour. Now let's pretend Brenda's group got a 99 miles an hour. It's going to vary, right? Just because you're using different data. Okay. Now, my question to you all, okay, how would we find the population mean? We would do the average, and we'd curse Bill Gates when he made us use the word average, right? Of the entire school, right? Okay. So in the simulation, we wanted our mean to be 100. Let's see how close we were. 99.5, that's pretty darn good, right?
Wow.
Okay. So the parameter, the population mean in this case is 99.5. Now let me ask you a question. What if I did a mean of my means? Okay. So what that means is I want to take a mean of all of these numbers here. Okay. Now the true mean, the parameter is 99.5. So my question is, if I take all of this data here, okay, before I press enter, I want to ask you if you think that the mean of my means will be exactly the same, or will it be slightly different than my population mean? So I'm going to have you guys vote. Who says it will be exactly the same?
Exactly like 100?
No, 99.
99.5.
Oh, I
It says it will be exactly the same. Nobody? Who says it will be different?
Yes, everyone.
Everyone, okay. So here we go, drum roll.
Oh,
It's exactly the same. How about that? Okay. So I know we covered it up on the board, but this is an example of what we call the central limit theorem. Okay. What the central limit theorem says. Now, by the way, okay, let's talk a little bit about this graph down here. Now, I think if we had done our histogram normally instead of used Excel, that's why I don't like you to use the Excel histogram, because it doesn't work very well. It would have looked more like a rectangle, but even though it didn't, it's still a right skewed distribution. Would you say this looks like a bell curve? No. Okay. So here's what I want to do. Again, this time we're going to do a histogram of just the means, the sample means. Okay? So my question before I draw this histogram, and hopefully this will work, we're using Excel, so who knows. But do you think that it will look skewed like a rectangle, or skewed, or will it look like a bell curve? Who says it will look skewed? 1, 2, 3, 4, 5. Who says it will look like a rectangle? 1, 2, 3, 4. Who says it will look like a bell curve? Nobody? Okay, here we go. Suspense is killing me. Whoops. That's not what I wanted. I got to use my recommended charts. I forget. Histogram. It looks kind of like a bell curve. How about that? And that's what I just told you that the central limit theorem said, okay? So if I'm going to draw this on the board, this is how it would look on the board, okay? Stop sharing. Okay, so remember our underlying distribution is a normal distribution, okay? We did the numbers from 75 to 125, okay? Now, just looking at this, and hopefully you know the answer, if you were to estimate the mean on a uniform distribution that looked like a perfect rectangle, where would you guess that the mean would be?
Right in the center.
Right in the center, okay? Right in the center, and you would guess, so the center of this would be 100, okay? So that's just like the first graph that we did. It was supposed to look more like this, okay? Now, the question I have here is, okay, so this is my population mu equals 100, okay? Now, we did 100 samples of 9. Now, normally you want your sample size to be 30. I only used a sample size of 9 because I was pretty sure it would work, and it did, okay? What the central limit theorem says, that if you take a bunch of samples, it will become normally distributed about the mean, and the X bar will be the same, 100. Okay? And so this is an illustration of the central limit theorem. Okay? All right. So that's an illustration of what the central limit theorem does. Now, the next question I have, let's go back to our spreadsheet for just a moment.